Eighth grade. Today in math class, we're going to take a look at our cumulative test 8B as our practice test to help you prepare and complete test 8A. I'm showing you this strategy as a way in which to take something that we're learning and doing an example problem of on 8B and how you would apply that directly to solve 8A. So I would have these two things right on your desk ready to go from the get-go. Let's get into it. Number one says find the prime factorization of 50. Prime factorization, you're thinking of what is the smallest prime number that I can divide this number by, and then find those factors and break it down as far as I possibly can. So 50 is an even number, and I know that's going to be 2 and 25. 2 is a prime number. 25 can be broken down into 5 and 5. I would use that same strategy right here on number one. You'll see that Mr. Shane's going to refer back to how to solve it here and then how you would apply that here, not show you or give you the answer, but show you that there's a method to apply that knowledge directly in that exact problem afterwards. Let's take a look at number two. Number two says, a school conducts a survey about favorite subjects. A math teacher asks students in math class or math club to name their favorite subject. Give a reason why the sampling might be biased. We just looked at this in geography here. It shows up in math as well. Most members of the math club will probably name math as their favorite subject because they're in math club. They're choosing to spend their time doing so. Most people that are playing basketball, you probably get the gist of what their bias would be. Make sure that you read through to answer that question. Number three, a television station conducted a survey of the sports preferences of its viewers. The bar graph shows the result. Explain why the graph may be misleading. Notice how these are all really, really close together. It's probably because these values are so huge that you can't tell that there's a difference between those overall values. So the graph may be misleading because blank increments of the scale make the data value appears to be blank than they really are. We've got large increments, over 1,000 increments in between, where those are the number of viewers. Those large increments make the values appear closer together than they really are. In number four again, or number three here, you're looking at the misleading portion of the graph where those increments are and how that shows up. Number four, find the product 2.7 times 10 to the third times 2.4 times 10 to the fourth. Write this answer in scientific notation. To do this, you're going to multiply both of the decimals here, and then your product of exponents property means you can add those two things together, so you get 10 to the 7th. Then you simply have 2.7 times 2.4, which is going to give you 6.48. Multiply the decimals. Product property of exponents, take the two bases, add the exponents up. Number five, simplify 3 times a cubed b squared cubed. Means our product property rule says that this 3 is applied to each of the items inside here like it's the distributive property. Let me make sure that that gets on the screen so that you can see what's going on. Sorry. For number five, here you would have 3 cubed, which would give you 27. 3 times 3 is 27. Here you would have 3 times 3 here, which would be a to the 9th and b to the 6th. Again, for number 5, product property, that 2 is applied to the 6th, the x squared, and the y cubed to help you answer that. In number 6, it says simplify the expression of x to the negative 2nd m multiplied by in parentheses y over x to the negative 4th n to the negative 3rd plus 3x to the negative 2nd n to the negative 3rd. The directions tell us to distribute, then use the properties of exponents to simplify. First we want to distribute and write this all out. We would have, in this example, let's just use the space that we have on the side here to write this out in this first term. You would have x to the negative 2nd times y in the numerator. You'd have m x to the negative 4th n to the negative 3rd in the denominator. In the second term, you'd have x to the negative 2nd over m times, in the numerator, all of this material, 3 x to the negative 2nd n to the negative 3. And then if you're going to simplify this, you know that anything that is a negative gets changed into a positive in the opposite place. And where you have those positives and negatives change, then you can go ahead and combine terms that are on the same side or eliminate if they're in the numerator-denominator position. So in this case, for number 6, you're going to have n to the negative third come up into the numerator. That's going to be n to the third that's positive there. You're going to have x to the fourth come up to the numerator, so you would have x to the fourth up here and x to the second down here, both positive, and then you would subtract those because 4 minus 2 would give you x squared still in the numerator. Your y is positive still in the numerator, that stays. And then in the denominator, you would still have the m that's right down here, right? In the second term, then, you're going to have in the numerator all the things that are going to remain after all of these negative values go down into the denominator. So in the numerator, you still have the 3 here. And then in the denominator, because all those other values were negative, you've got an m, n to the third, and x to the fourth. Because the x squared and the x squared get put together, that's to the fourth, that's going into the denominator, and n to the third goes into the denominator because it was negative to start, and then you multiply by that m, which was in the denominator as well. So you have to pick out for the variables that are in the denominator where they can't equal 0. That would be m can't equal 0, n can't equal 0, and x cannot equal 0. Number 7, to simplify 3c squared plus 2cd squared minus c squared plus 3cd squared minus c squared. Rearranged and add the like terms. I like to use the circle method or the shape method to kind of put those things together. These two are the same term, and this is the same term because it's c squared. So you've got 3 minus 1, which would give you just c squared, right? You've got 2cd squared plus 3cd squared. That's going to be 5cd squared, and those two things are added together. Number 8, simplify negative 4 squared. Notice the parentheses is not around that negative 4, so the negative does not apply in this case. So you'd have 4 squared, 4 times 4 is 16, plus a negative would give you negative 16. Notice how on the test the negative is included in that parenthesis, and you would multiply that negative each time. Take a look at number 9. Looks like we've got a little equation that relates exactly to what we just studied in science class this week. The formula F equals 9/5 C plus 32 expresses Fahrenheit temperature in terms of Celsius. Find the Celsius temperature when the Fahrenheit temperature is 185 degrees. Now, you can probably go back to your science textbook and find out where that opposite equation is, or you can plug in what they give you as the Fahrenheit temperature and solve for Celsius in this example. That's what they want you to do. So you're going to plug in 185 equals 9/5 times C plus 32. You're going to subtract 32. Subtract 32. 185 minus 32 is going to be 153. And then you're going to multiply by 5/9 times 5/9. And guess what? That's the exact same equation. 153 times 5/9 for number 9 is going to give you 85 degrees Celsius. In your actual test, you're doing the same thing. Follow that protocol. Plug in the value, what you know for the Fahrenheit, transition it into Celsius, or use the equation that I have given you in your science textbook. On the back side, number 10, a traffic light casts a shadow 23.4 feet long. A girl who is 4 feet tall casts a shadow 5.2 feet long. The triangle drawn with the traffic light and the shadow is similar to the triangle drawn with the girl and her shadow. How tall is the traffic light? So we have known information. We've got unknown information. We've got to solve for that unknown. We're comparing 23.4 to 5.2. We're comparing 4 feet tall to x feet tall. In order to do that, you would cross multiply and divide. In this case, 10 is going to be 18 feet. Number 11. A bag contains 3 green marbles, 7 yellow marbles. Find the probability of drawing a green marble, keeping it, and then drawing another green marble. Write the probability as a fraction in simplest form. So to find green the first time, it's going to be 3 out of the total of 10. And then the second time, you're going to keep it out, so your total goes down to 9. This time, if you kept the green marble, how many green marbles are in there in that result? You would have 2. So if you multiplied those two things together, 3 times 2 is 6. 10 times 9 is 90. Can you break that down? How many times does 6 go to 90? I believe that's 15. So you got 1 in 15 chances of getting both of those in a row. That looks really similar to what you're using here. You've got 6 and 4 as your probability. Now you're trying to get red and red. Put those two things in order and multiply as they're in that sequence. Number 12. A traveler from Europe wants to convert the distance 700 miles to kilometers. If 1 mile equals 1.61 kilometers, what's the distance between the two cities in kilometers? You take 700, multiply by your conversion, 1.61. You're going to get 1,127 km. In number 13, it says determine whether the sequence of 1, 12, 23, and 24 is an arithmetic sequence. If yes, find the common difference. Common difference is how much does it go up by? 1 to 11 is, 1 to 12, it goes up by 11. 12 plus 11 is 23, goes up 11. 23 to 34 is 11. So you would say for number 13, yes, it's a common difference. Common difference is 11. The next two terms then after 34, 34 plus 11 is going to be 45. 45 plus 11 is going to be 56. For number 14, find the difference. You're going to subtract the two values. You've got two negatives here, which turns that into a positive. You would have 5.4. Negative 1 plus 5.4 for number 14 is 3.6. You're going to see something similar show up. Two negatives make a positive. Then you're going to subtract anyways because you've got a difference between those two items. In number 15, you're solving by using your distributive property here. You would multiply, and then solve with like terms. Negative 3 times 3y is going to give you negative 9y. Negative 3 times negative 7 is going to give you positive 21. And it looks like you've got negative 9y, positive 21 on both sides. That means no real solution. If they ever have the exact same thing on both sides of the equal sign, that's going to throw things off. That doesn't work. For number 16, you're doing the same, 15 for test A, you're doing the same thing. You're going to use the distributive property here and look to see if they have the same equal sign. Looks like it's going to be a giveaway right there for you. It might be the same answer we just found. 16, 5b minus 6 minus 7b plus 2 equals 2. Solve for b. That means get b by itself. Add the like terms where we can. Negative 6 and positive 2 is going to be negative 4. 5b and negative 7b is going to give me negative 2b, and it's going to be negative 4 equals 2. I would add 4, I would add 4. Adding 4 to 2 is going to give me 6 on this side, and I've got negative 2b, divided by negative 2, divided by negative 2. b is going to equal negative 3. Add like terms. These are two-step expressions, so you do the opposite operations. To solve for b, get b by itself. 17. Negative 0.4x plus 0.7 equals 4.3. Solve for x. You're going to multiply each term by 10 to get rid of those decimals. So this moves, and this moves. In my new problem, looks like this. Negative 4x plus 7 equals 43. Two-step equation. Minus 7, divide by 4, divide by 4. 43 minus 7 is going to give me 36 divided by 4. For number 17, it's going to be a total of x equals 9. And that's a negative 9 because the value here was divided by negative 4. In number 18, put these in order from least to greatest. Obviously, negative numbers are smaller on our number line, so negative 2, negative 0.2, negative 1/2 goes here, negative 0.2, and then 0.2. Oftentimes people get confused with the decimals, but the decimal number that's positive is larger than any of the negative numbers in this case. Same thing's going to show up here, except you now have different fractions and decimals. You might need to put those all in decimal form and compare them, or all in fraction form and compare them. Number 19 and 20. Number 19, you're going to evaluate by plugging in for x and y. Here's going to be a 6. This is going to be a 2, a 6, and a 2. You would multiply 7 times 6 plus 3 times 2 minus 6 times 2. 7 times 6 is going to give you 42, plus 3 plus 2 is 12, minus 6 times 2, 18, is going to give you a total of 36. Number 20, one pretzel has 20 calories. Write an algebraic expression for the total number of calories in n pretzels. Well, if that's our multiplying factor, we would simply plug that in. You can see that in test 8a, you have problems that are exactly the same. You're going to use your substitution here, and then in this example, it gives you what that rate is that you would then be multiplying by algebraically. Hope that helps you complete your cumulative test A. Again, watch Mr. Shane do the problem on 8B and apply that on your own on test 8A. God's blessings.